Hi, I'm Will from Tested.
I'm Adam.
We're here in your cave, Adam.
We are.
You collect a great many things.
I do.
A variety of interests.
You might even say I collect collections.
That's true. You have a bit of everything.
A bit. Nice.
You see what I did?
Well done. I like how you did that. So this is a key thing that I like collecting, which is arcane technology. Mm-hmm. And this is a kind of arcane technology very few people are paying attention to. This is a bit.
One bit.
One bit, which means this is one yes or no, 0 or 1 logic gate.
So it uses a vacuum tube on the top.
There's a vacuum tube.
Transistors and resistors and stuff.
Yeah, the vacuum tube is labeled IBM. This is from a 52, 53 series IBM mainframe.
So this is older than everyone in this room right now.
Absolutely.
This is interesting because they could replace it instead of by replacing the tube when the tubes would blow, because that was what happened with this kind of memory in the old days. Was the tube would blow, you'd have to go in, turn the machine off, find out which one was blown, pull it out and put the new one in, right?
Exactly. And this innovation of being able to pop it out and fix it one bit at a time was actually, I bought the magazine ad that celebrates this unit. I mean, this is like, all this isn't that very expensive.
Look at that computer, it looks like a washing machine.
And this is probably 1 kilobyte, right? This is probably a 1K computer.
And just to be clear, the innovation is it has a handle.
That's it. That's the handle.
There's a handle. So okay, so this is 1 bit.
This is 1 bit. Now, this is the second piece of super arcane technology that I bought. The first was actually inspired by, there's a seminal book about computing called The Soul of a New Machine by Tracy Kidder.
Never read that.
It is a it's a thrilling book about the development of the first, I think, 386.
Okay.
Right? And back then,
the first modern processor.
Yeah, the first modern processor. And they were talking about all sorts of things, like somewhere in IBM's lab are binders full of zeros and ones. It's the actual root code in binary in paper form, right?
It's got to be a room full of binders.
So yeah, and so there's they get right down to the nuts and bolts, and you kind of really start to understand them. And at one point, they're interviewing Mitch Kapor, the inventor of Lotus. Mm-hmm. And the guy started Lotus and the first spreadsheet programs. And Mitch Kapor supposedly had a byte on his desk. And I was telling my wife about it. This was about 8 years ago. And I was like, yeah, he had a byte. It was a byte. Like, how amazing is that? And then I went on eBay and I found someone in Schenectady, New York. Of course, it'd be in Schenectady, New York,
of course.
Right? And she had a bunch of these for sale, and I bought one. This was not cheap. It was about $350.
Wow.
But this is an original IBM byte, so it's 8 bits.
8 of these. 1 bit per tube.
Yes.
I assume each one does a different signal or something like that, and then it all connects into the bottom.
Yes, no, depending. Yeah. And perhaps can save its state. The innovation with the byte here, and this is from a 1956 series 703 IBM machine.
Okay. Perfect naming scheme.
The innovation for this is that it has a little cam lock here, so that you could actually repair the memory 1 byte at a time rather than 1 bit at a time.
So you can be 8 times as efficient.
8 times as efficient, yes. You can pull this out, troubleshoot it, put a new one in, et cetera, et cetera.
So this is 8 bits, 1 byte.
Yes.
This is what I would say is probably the smallest unit of kind of the modern computer, right?
Absolutely. And just to be clear, all computers operate on a set of gates that say yes or no, 0 or 1.
Right.
One state or the other. And that's what these are, 8 of those states, allowing us to, you can represent 1 integer with this.
So the difference, the thing that's changed, is that instead of using vacuum tubes now, we use semiconductors that can be printed very small with photolithography and all sorts of other increasingly advanced lithography every year.
That's within the computing power, and then in memory storage, we store electromagnetic particles on platens, and then now in flash memory. So let's move on to the next.
Stepping forward.
Bit.
Okay.
Byte.
This is very straightforward so far.
Right.
Like this is 1/10,000,000th of an MP3, right?
Right. Yes.
Okay.
Yes. Exactly.
Perfect.
This is a gigabyte. This is a gigabyte in 1981. It weighs.
So this is 6 years younger than me.
6 years younger than you. It weighs 75 pounds.
It really does. We got it down off the rack.
It took 3 of us.
Really heavy.
Yeah.
And you can't. I don't know if you can see it, but I'm not going to try to tilt it, but there's spinning platters inside here.
You can hear it. Listen.
Oh,
that's like some dust I've
sounds like computing. And this is the predecessor to the modern hard drive. What we've seen before was RAM.
Yes.
This is long-term storage.
Long-term storage. Spinning platens. These are basically aluminum discs, which actually probably really nice aluminum. I can crack it open and use it. When I tweeted that I'd received this, I got lots of tweets from people saying they used to have to fix these.
Oh.
Which is like when some part of the mainframe went out. Look, it's a hard drive with 2 handles in order to remove it and swap it out.
This is a gigabyte.
This is a gigabyte.
This was just people don't appreciate this now. A gigabyte in 1984, 81.
So, yeah, 81.
Was a ludicrous amount of storage. My first computer that I bought in 1993, I think had 80 megabytes of hard drive.
Right, no, this is a massive amount of memory.
Unbelievable.
Absolutely.
I mean, this would probably cost a couple $1 million at the time. It was probably very expensive.
I hope not. I would imagine. It did occur to me that it's also probably riding on a pair of really, really sweet bearings.
Oh, I'm sure there's great bearings.
Right, like they're meant to spin at like 1,000 RPM for 5 years.
Oh yeah, and then this guy in here has probably got some sweet electromagnets that move the heads in and out in the right places.
I can't bring myself to take
Don't part it out. No, don't do that.
I want another one so I can part it out.
There you go.
You
That's
know
the
there's
thing
going to
to
be
do.
some like really good stuff for my R2D2 in here.
The discs in here each weigh 4 or 5 pounds each. It's like the one that we used to have in our office. So this was a gigabyte, 75 pounds. It's huge.
Yes. So wait, we should be clear.
We took notes. We did a lot of math.
Gigabyte, byte. Actually, we should do it the other way. 1 byte, 1 gigabyte. 1 billion bytes.
1 billion bytes. So there are a billion of these guys in here.
Yes.
Well, actually, it's more like 1,073,000,000 something.
Yeah, exactly.
It's like 10 to the 24.
Yes, it is exactly 1,073,740,000
It's exactly.
of these in here.
I don't know how they all fit, but now I understand why it weighs 75 pounds.
It would seem, except that we've also got this.
So this is another hard drive. This is something I just carry in my bag every day.
Now you carry this in your bag.
It's
this is 1,000 of these.
Yeah.
This is a terabyte. It's 1,000 gigabytes.
So it's a trillion of these.
A trillion of these.
It seems unlikely that would fit in there. We did some more math.
Yeah. So here's where it gets kind of exciting. If you wanted to build a modern computer utilizing these
vacuum tubes,
if you just to get a gigabyte would take the volume of that computer would be 1.5 cubic kilometers.
So a kilometer by a kilometer,
1,000 meters by 1,000 meters by 1,000 meters.
That's a real big block of memory.
It gets better.
Okay.
So if you wanted to store this much memory using vacuum tubes, it would be 1,500 cubic kilometers.
Of those cubic kilometers.
Yes.
So you'd have to have a lot of people running around replacing vacuum tubes.
Could you imagine?
It would be the worst job ever.
1,500 cubic kilometers. It's like bigger than it's bigger than all the 7 wonders of the ancient world and the modern world combined times a million. Right?
Well, and then when you think about the scale of things like Amazon's Web Services Cloud, S3 Cloud,
right,
where they're adding terabytes and terabytes every minute of every day, and you're looking at petabyte and exabyte size capacity, this gets insane.
It totally is completely mind-blowing when you realize how much is actually going on inside your computer just to make it seamless for you.
And play MP3s.
And to play MP3s. And you think that like our dads would maybe work with something.
My grandmother did.
Did she?
Yeah. Exactly.
You know, I met somebody, some of the first real computing in the 20th century was happening under top secret operations at Bletchley Park in England during World War II, while Alan Turing was helping to decode the Enigma.
The bomb.
Yes, the bomb, exactly.
The bomb.
And one of the things they had at Bletchley Park were rooms full of women crunching numbers.
Yeah, computers.
And those women were called computers.
My grandmother did in World War II.
Did she really?
So yeah, she was a computer. Not at Bletchley Park, but on the other parts of it. Anyway.
So there you go. There's a little computer lesson in my collected random detritus from the...
60 years from here to there.
60 years from here to here.
That's amazing.
1 trillion of these in here.
It's amazing.
I am sure that some of our math is wrong.
Almost certainly.
We will be delighted to be correct.
It's my fault. Send emails to me if we mess up the math.
It's been a long time since I've done notation.
Yeah, no kidding. And imagine another 50, 60 years from now, what this is going to look like it's
We're given Moore's law, right?
Keeps getting smaller, keeps getting faster, keeps getting cheaper.
Yeah.
Thanks, Adam. We'll see you guys later with more from the cave.
Bye, guys.